In this chapter, we'll go over aldehydes and ketones, their nomenclature, and their preparation and reactions. So to start with, aldehydes and ketones, they both share carbonyls. The carbonyl of the aldehyde is normally at the end of the structure. This is why the hydrogen is a must to show that it's an aldehyde. If the R is replaced by a hydrogen, then this is going to be the simplest form of the aldehyde. For the ketone, its carbonyl has to be within the structure, so both sides of the carbonyls need to have an R group. When carbonyls are placed next to each other, they are going to create a temporary dipole. The dipole is due to the electronegativity of the oxygen. Because oxygen is more electronegative than carbon, it's going to pull electrons away from the carbon and make the carbon partial positive. So you're going to have a temporary dipole between the oxygen, which is partial negative, and the carbon, which is partial positive. This intermolecular force, we call it a dipole interaction. When carbonyls are placed next to each other, there is no hydrogen bonding between them. Just as a revision, that hydrogen bonding exists whenever a hydrogen is connected to an electronegative element. And the electronegative element is oxygen, nitrogen, or fluorine. And that hydrogen needs to interact with an electronegative element. This is the hydrogen bonding in there. Okay, so that is the hydrogen bonding there. So the electronegative element is also oxygen, nitrogen, or fluorine. In carbonyls, we don't have a hydrogen connected to an electronegative element. So if you place two carbonyls next to each other, there is no hydrogen bonding. On the other hand, if you place a carbonyl up to 5 carbons, okay, next to water, then in this case, you have the case of a hydrogen connected to an electronegative element, and that hydrogen is going to interact with an electronegative element. So carbonyls, they hydrogen bond with water. When they hydrogen bond with water, this means that they are soluble in water. But of course, up to 5 carbons, not more than that, or else you're going to have a hydrocarbon, a long hydrocarbon chain. Even with the hydrogen bonding, it's not enough to be soluble in water. Remember that hydrogen bonding increases the boiling point and the melting point. And the more intermolecular forces, the higher the boiling point, and the higher is the melting point. So if I am comparing a simple alkane versus an aldehyde versus an alcohol, then you would need to look at the type of intermolecular forces of each. Alkanes have weak van der Waals forces. These are very weak London forces that exist between hydrocarbons or between two compounds that come closer to each other. The aldehyde has also van der Waals forces and has dipole-dipole interaction. And the alcohol has the van der Waals forces. It has dipole-dipole interaction, and in addition to that, it has hydrogen bonding. So this is why we are expecting that alcohols have a higher boiling point, they have a higher melting point. To name aldehydes as a common name, we are going to name the carbon chain, and then we're going to put the word aldehyde at the end. Where you have just one carbon in there, and that is called formaldehyde. Acetaldehyde is whenever you have two carbons in there and the hydrogen. So that is going to be an acetaldehyde. A 3-carbon aldehyde, including, of course, the carbonyl of the aldehyde. So when you name, you always include the carbonyl of the aldehyde with the numbers of the carbons. So that is called a propione aldehyde. Butyraldehyde is a 4-carbon chain, including the carbonyl of the aldehyde. And then a 5-carbon chain, including the carbonyl of the aldehyde. That is going to be a valor aldehyde. To name aldehydes as IUPAC name, always we choose the longest carbon chain that includes the carbonyl in there. Let's say if we have a bromine in here and if we have an OH in there. So you choose the longest carbon chain that includes the carbonyl. You give your carbonyl always the lowest number, and in the case of the aldehyde, you always give it carbon number 1. So always aldehyde gets a priority in naming over any functional group, any small functional group. If you have an alcohol, aldehydes have a priority in naming in there. In fact, aldehydes, they have a priority in naming over ketones, alcohols, amines, ether, and alkenes and alkynes. So you start numbering from the carbonyl in there, and you try to give the substituents the lowest number possible in there. So this is 5, this is 6, and this is 7. Name the longest carbon chain. This is heptane, and drop the E in the heptane and add an Al. The rule in the naming is that you cannot have two vowels next to each other. So if you have two vowels next to each other, always go ahead and drop the E. Ending of the aldehyde is an Al, and then name your substituents. So bromine here is on carbon number 3, and the OH gets the name hydroxy because now it is a substituent. Arrange them in alphabetical order, and the name is going to be 3-bromo, 5-hydroxy, and then hepta now. So let's erase that one, and that is going to be hepta now. And there is no space between the hydroxy and the heptanal. Make sure that you add your dashes between the number and the letter. If we have a double bond within the aldehyde chain, then in this case, you would need to include that double bond in the long carbon chain along with the aldehyde. You start numbering from the aldehyde every single time. You give the aldehyde the lowest number in there. This is 6 and this is 7. So this is a heptene. It's a heptene because it is an alkene in there. This is your functional group. And you also have another functional group, which is the parent name, which is the aldehyde. So what you need to do over here is simply drop the E in the heptene, and you're going to replace it by an Al. So your name over here is going to be a heptane now. The Al is automatically on carbon number 1. So the En now you need to give it a number, and that is going to 3. So the name over here is going to be 3-heptane Al. You can also insert the 3 before the En, and the name is going to be hept 3-ena. This means that the 3 is belonging to the double bond because the carbonyl is already on carbon number 1. If you have more than one double bond, so let's say if we have something like this, and this is going to be your carbonyl, you have a double bond here, and you have a double bond in here. Again, you choose your longest carbon chain, include as much functional group as you can in the long carbon chain in there. Give your aldehyde the first priority. This is 4, 5, 6, 7, and 8. And go ahead and name this as an alkene first. This as a diene first. And that is going to be an octadiene. So all what you need to do is drop the E and add an Al. And then number where your double bonds are. So my double bonds are on carbons 3 and on carbon number 6. So this is going to be 3,6 octadienyl. Or I can insert the 3 and 6 before the die. So that is going to be an octa 3 6 die in F. Don't forget, whenever you have double bonds, you have to include the stereochemistry. So on 3, this is an E, and on 6, this is an E as well, and then the rest of the name. If you have two aldehydes that are in the same chain, they both need to be terminal though. So let's say if we have two aldehydes over here, you always choose the longest carbon chain that includes both aldehydes. So let's say if we have something like that. So always make sure that your longest carbon chain includes both aldehydes, even though if your chain is a shorter chain than the long actually chain. So over here, this is going to be 1, 2, 3, 4, 5, 6, and 7. If I go this way, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So go with the chain that includes both aldehydes in there. Start numbering from any side of the aldehyde, but make sure that the first substituent gets the lowest number. So that is going to be 1, 2, 3, 4, 5, 6, and 7. Now I am going to treat this alkane to be a substituent. And this alkane is 1, 2, 3, 4, 5, and 6. And this is going to be a hexyl group. The hexyl group is on carbon number 4. You name your chain that has the both carbonyls on it, and this is going to be a heptane. I'm just going to name it in the form of an alkene first. Now, because I do have two aldehydes, now both of these aldehydes in there, I'm going to call them di-al in this case. So because there is a di separation between the Al and the E, you keep the E and you don't drop it. You don't have to put numbers in there for the Al because I know that both of those, they are terminal. Each one needs to be at the end. And then on carbon number 4, I do have my hexyl. When aldehyde branches out of a cycle, so if I have a cyclohexane, then in this case, this carbon will be named as a carb. And then since it's an aldehyde, it's going to be a carb aldehyde. So the name is going to be a cyclohexane carb aldehyde. When aldehyde branches out of a cycle of a benzene, then the best way to call this or to name it, this is going to be a benz carbon. So it's a benzylic carbon. When we say benz, we mean a benzene that is connected to the carbon. So it's going to include both of those. So this is going to be called benz aldehyde. Benz aldehyde is a common name, but we mostly use it also in IUPAC. You can name it as a benzene, a carb, and an aldehyde in there. This name, we don't use it much, but you can do that, and you can name it as a benzene. So if you use the word benzene, then you are separating now the benzene from the carbon that is connected to it. If you use benz, benz means that you have a benzene connected to a carbon because you are working with the benzylic carbon. So now that is going to be a benzene. I separated that carbon, so now I have to name it alone, and the name is going to be a carb and then an aldehyde. And all of those are going to be one word. There is no separation between them. Benzene carb aldehyde is considered to be an IUPAC name. If I have two aldehydes that are coming off the benzene, then in this case, those aldehydes, in our case, they are on one tooth. So it's going to be named ortho. It's going to be benzene dicarb aldehyde. If benzene is a substituent on the long aldehyde chain, so if you have an aldehyde here and aldehyde there, and benzene is a substituent, then in this case, that benzene is going to be named a phenyl group. You start your name from one end of the aldehyde. Make sure that the substituent gets the lowest number possible. So that is going to be 1, 2, 3, and 4. If I start from either sides, the benzene is going to be on 4. So now the benzene is going to be given the name phenyl. So the name is going to be 2-phenyl. Okay, continue the numbering in there. This is 5, this is 6, and this is 7. So the name is going to be heptane. Now, because you have two carbonyls in there, then you're going to use the prefix di. No need for you to drop the E. You can keep the E and put an AL at the end, and the name is going to be a heptane dial. Or if you want, you can drop the E. If you drop the E, the name is not wrong. It's still right. So if you drop the E, then the name is going to be a heptane di. Whatever route you choose, it is right. So at the end, the name is going to be 4-phenyl heptane dial. I'm keeping the E in here in the notes. I'm dropping the E, but you can keep the E as well. So, or keep the E. Now, to name ketones, you always choose the longest carbon chain that includes the carbonyl. You give the carbonyl the lowest number possible in there. Definitely when ketones are included in the chain, they're not going to take carbon number 1, but they are going to take the lowest carbon possible in there. So that is going to be 3. You name the parent name, it's going to be a heptane. You drop the E and you add an O and E, so it's going to be 3-heptanone. Or you can put the 3 between the heptane and the O. If you have another functional group with the ketone, then you want to make sure that the long carbon chain includes that functional group as well. Okay, ketones have higher priority in naming than the alkene. Number your ketone and give your ketone the lowest number, not the alkene, it's the ketone. So this is going to be 4, this is going to be 5. This is a pentene carbonate chain. Since you have two functional groups and the ketone takes a priority, so it's going to be at the end in there. So the ending is going to be an O and E. I'm going to drop the E in there. But since it's a ketone, I need to give it a number. And I need to give a number also for the double bond. So the double bond is going to be 4 pentane, drop the E, and then put a number for the carbonyl, and then it's going to be 2O, and the name is going to be 4-methyl. Don't forget your substituent, 4-pentane 2O. You can also take the 4 and put it before the EN, and the name is going to be 4-methyl pent 4-en 2O. Now, if we have a cyclic ketone, then in this case, the ketone carbon is going to be carbon number 1. So the ketone carbon, this is the only case where the ketone carbon is going to be number 1 in cycles. Okay, so in this case, your name is going to be 2,2-dimethyl, and it's going to be a cyclohexa. It's a hexane, so you drop the E and add O and E at the end. So it's going to be a cyclohexanol. You don't have to put number 1 in here. So number 1 is not necessary. Now let's say, for example, if we have both aldehydes and ketones in the same molecule in there. So let's say if we have an aldehyde here and if we have a ketone in there. The rule says that aldehydes always have a priority. So aldehydes have a priority over ketones. So this means that your ending is always going to be in Al. So you're going to choose the longest carbon chain that includes both functional groups, if you can, and then give the aldehyde the lowest number. So start numbering from the aldehyde every single time because the aldehyde is terminal. This is going to be 3, this is going to be 4, 5, and 6. So your ending is going to be hexanal. And then if the carbonyl is not the parent, this is the rule over here. So if carbonyl is not the parent, then you name it as an oxo substituent. So here, the carbonyl of the ketone is not a parent. The parent name is the aldehyde. So in this case, you're going to name it as an oxo. So that is going to be 4-oxohexanal. This is for to name ketones as common name. This is for smaller ketones. You name both R's that are connected to the carbonyl, arrange them in alphabetical order, and add ketone at the end. So that is going to be an ethyl, methyl, and a ketone. There are 3 structures that you are responsible for their common name. Acetone is the simplest ketone in there. And this is the common name of 2-propanone. And then you have acetophenone. The aceto is the CH3 carbonyl. This is the aceto part. The phenyl is the benzene, and both they are ketones, so this is why its ending is ONE. So that is going to be the common name for this structure. If I want to name it as an IUPAC name, this is going to be phenylethanone. And then we have benzophenone. It's both common and IUPAC. Benzo is a name that we give whenever the benzene is connected to a carbonyl. Then we give it the name benzo, Z-O in there. So whenever I say benzo, I mean the carbonyl together with the benzene, and then this is connected to a phenyl, and it's a ketone, so this is going to be a phenol. There's a difference between a benzo or a benzyl or a phenyl. A benzyl is a benzene connected to a carbon, and a phenyl is just the benzene ring.